All right, welcome to this explainer. Pull up a chair. As a junior developer, it's time to get you ready for production. Today, we are officially escaping tutorial hell, dropping the endless videos and getting you to build real, actual things. Look, as a senior dev, I've got to be honest with you. It is incredibly easy to sit there, completely zoned out, watching 10 hours of coding videos, only to open a blank editor and realize you literally can't write a program from scratch. If you want this syntax to actually stick in your brain, you have to write code every single day. Make a calculator, write a tiny automation script, whatever. Binge watching won't get your pull requests approved. Now, when you inevitably get stuck, and you will get stuck, here is your professional learning toolkit. Need hands-on syntax practice? Go to Codecademy. Want to handle PDFs or Excel files? Read Automate the Boring Stuff. For deep dives into the mechanics of why things actually work, Corey Schaefer is your guy. And for building practical apps, hit up Tech with Tim. The secret here? Pick just one path and stick to it. Consistency is a real game changer.
Section 1. Professional Data Foundations. Let's start our codebase tour by looking at the actual data building blocks you'll be using literally every day.
Okay, so here's a quick cheat sheet for data types. You've got strings for text, integers for whole numbers, floats for precise decimals, and booleans for triggering true or false logic gates. But pay close attention to that professional use case column. Here's the trap. User input always comes in as a string, period. If a user types the number 3 and you try to do math without explicitly converting it to an integer first, you won't get math. You're just going to mash text together and crash the whole script.
Once you have that data safely stored, you've got to parse it efficiently. Enter the slice operator. It uses this brilliant little start, stop, step syntax right inside square brackets. And this perfectly illustrates how we parse data quickly without writing massive, clunky loops. Want to skip every other letter or grab a specific chunk of a list? Just tweak that step value. It's clean, it's professional, and it's exactly how we rip dates out of massive, messy server log files. To really manipulate things, you need to know your practical string and list methods. .find gets you the exact index position of a character, while .count tallies up how many times it actually appears. And hey, you can even use slicing to inject new data right into the middle of a list. We use these methods constantly in the real world to validate inputs. Imagine using .count to instantly reject a password just because it has an invalid underscore. Boom, validated. Section 2. Directing the app's flow. Now that we have our data toolkit securely in hand, let's control how our application behaves dynamically using conditional logic. Think about the logic flow for a roller coaster app. Step 1, check if the user's height is under a meter. If so, reject. Step 2, check if their height is over 2 meters. Again, reject. Finally, our else fallback simply lets them on the ride. Now remember, Python reads line by line from the top down. So the absolute key here is that when we use if, elif, and else statements, the code stops checking the exact moment a condition proves true. It doesn't waste memory reading the rest of the block. But, in production, conditions are rarely that simple. That's why you need chained conditionals. And means both sides have to be true, or means just one side needs to be true. And not, that completely flips a true or false condition. When you're validating complex permissions, like making sure someone is an admin and their account is currently active, chaining keeps your logic super clean. It saves you from falling into a deeply nested, awful nightmare of if statements. Okay, let me save you from a classic trap I see a lot of juniors fall into: overcomplicating for loops. Don't wrestle with index numbers and the range function if you don't have to. Whenever possible, just iterate directly by item. A simple for item in list is vastly cleaner, it automatically stops exactly when the list ends, and it just hands you your data without making you manually track index numbers. Section 3. Writing reusable modular code. Let's move on to scaling up your code into functions so the rest of the development team can actually use it. Because as a professional, you absolutely cannot be copy-pasting code all day. You use functions. It's a reusable block defined by that def keyword, holding parameters that do specific tasks when called. Functions are how we avoid retyping the same logic over and over. Imagine writing an acceleration formula just once, and then passing it different mass and force arguments everywhere else in your app. Call it, use it, and move on. And we can totally scale this up. You can pass multiple parameters, or even better, set optional parameters with default values, just in case the caller forgets to provide one. Plus, why reinvent the wheel? You can import built-in modules like math or OS. You can even create your own shareable modules by importing entire files from your teammates, which keeps your main script looking incredibly organized and lightweight.
Now, here is a concept that will cause massive headaches if you mess it up: scoping. Think about local variables. They are contained safely inside the little fenced yard of your functions. Global variables, on the other hand, are accessible everywhere. Modifying global variables might sound convenient, but it creates extremely dangerous side effects that can detonate completely unrelated parts of your code base. Just keep it local.
To truly write professional Python, you've got to wrap your head around objects and classes. Basically, these are custom data structures where your variables become objects equipped with their own built-in attributes and methods. Understand that absolutely everything in Python is an object connected to a class. That is exactly why a basic string variable automatically has access to methods like .strip. You aren't just writing raw logic, you are utilizing built-in powers.
Section 4, Surviving Production. Let's wrap up this explainer by looking at the messy reality of handling external files and live errors in a production environment. In the real world, data lives in external files. To do clean file reading, you open a text file in read mode using a lowercase r, read the lines into a list, and then iterate through it. But here is the real professional trick. Always apply the .strip method. Text files hide invisible escape characters, like \n for new lines. If you don't scrub those out, your data formatting is going to be completely ruined. And finally, the harshest reality of all: users. They will inevitably try to break your app. Step 1, try a risky operation, like converting random text into an integer. Step 2, catch the specific error with except if it blows up. Step 3, handle it gracefully by just prompting the user to try again. Never let bad input crash your application. Wrap it in a try/except block. The user might fail, but your server shouldn't. All right, that brings us to the end of our mentoring session. You've got the data foundations, the syntax, and the defensive mindset of a senior developer. The tutorial binging stops right here. But look, all this knowledge is totally useless if it isn't applied. So I want to know, what real-world project are you going to build today to prove you're ready? Get to work, and I'll review your code in production.